So we are still continuing with factoring today, but we're going to take this a little bit further than what we've talked about up until this point. So basically what we did all of last week was we were looking at factoring polynomials as long as it only split into two things. So we were sort of talking about, so we're still in factoring if you're wanting a label for your notes. So this isn't necessarily something you need to write down, just something I think that we might want to consider here. We have been kind of talking about if we're factoring 10, we can split 10 into 2 and 5, and so our answer is 2 times 5. We now want to take that a step further with polynomials and say, okay, what happens if we want to factor 20, right? 20 we can split into 2 times 10, but we're not done yet. We still need to split that 10 into 2 times 5, right? We sort of do it in two separate steps. And that's the exact concept we want to apply to polynomials today. Okay, so let's say we have something like 2x squared plus 14x plus 24. Now, you might be tempted when you look at this problem to go, oh, it has 3 terms, it's a trinomial, so I can multiply 2 times 24 and start listing my pairs. And you wouldn't be wrong. You absolutely could do that. However, what I want to try and get your brain to start thinking, and a good habit to start, is to always check and see if there's a GCF first. So if we're asked to factor, we want to say to ourselves, okay, is there a GCF? Okay, and that's sort of always going to be our step one. Not because it has to be, okay, but because it's going to make your life a lot happier. So can we think of a number that goes into 2, 14, and 24? And hopefully we say yes. This has a GCF of 2. And so when we pull that out, we get x squared plus 7x plus 12. Okay, that's our GCF, and so now we're here. Okay, and if we think about this like a factor tree, right, just like that 20, this is like us splitting that 20 into the first 2 pieces. 2 and 5, or 2 and 10, except now our 10 is this big old x squared plus 7x plus 12, right? We've done that sort of first split. Then what we're going to do is we're going to look inside the parentheses, and we're going to see if we can factor that. Oh, I'm squishing that in. Okay, so now if we look at this x squared plus 7x plus 12, that's a trinomial. And so now we can multiply the 8 times c. But now instead of multiplying 2 times 24, which are larger numbers, we're going to be multiplying 1 times 12, which is much smaller. Okay, and so we'll list our pairs. 1 times 12, 2 times 6, 3 times 4. Okay, and we want our set that will add up to b. So our set that adds up to b here is 3 and 4. Now, it's even nicer that we factored out the GCF here, because now that the GCF is out, this has an a value of 1. Right? Up here we had an a value of 2, so we would have had to go through and rewrite and do the long way of factoring by grouping. But here, because a is 1, we can just split this into 2 binomials, where we get an x plus 3 and an x plus 4. Okay, and so now we're saying that that x squared plus 7x plus 12 splits into these two. Okay, now if I wanted to prime factor the 20 over here, this would prime factor into a 2, and a 5. Right? We'd use all 3 of those. So that same idea is happening here. We want every piece that we didn't split up. So this piece, and this piece all count in part of our final answer. So we'll have 2 times x plus 3 times x plus 4, right? And so we have 3 factors that make up this original problem. Just like 20 would prime factor into 3 numbers, right? Here we have that same thing. It's just that we're dealing with polynomials. Okay, now again, you don't have to write this down. I just want to show you that so you see this. Now, just in case you mess up or whatever, and you see this problem, you do 2 times 24 is 48. And so you start listing your pairs. 3 and 1, 16. 4 and 12. 5 and nothing. 6 and 8. Okay, and so you pick your pair of 6 and 8, and you split this up into a positive 6x, positive 8x, right? We have to do this one the long way because A isn't 1. And you start factoring it by grouping. Do the same thing over here. Okay, you get this 2x plus 8 and an x plus 3, and you might go, but that doesn't match the answer that we got over here. Well, you're just not done yet, right? So if you look, this 2x plus 8 has a GCF that we could factor out of it. Right? So just like if we were prime factoring 20, someone could have split 20 into 4 and 5 to start with. And right, that doesn't match what we did over here. But if we kept factoring, we would get down to that exact same answer eventually. Okay, so you can always catch that GCF at the end, but if you factor out the GCF at the beginning, life is so much happier and easier. Okay, and so this is our final answer. Okay, so let's look at another one. Let's say we have 3y to the third minus 33y squared plus 54y. Now, this problem, we don't have a choice. We can't start multiplying a times c because this isn't in the form ax squared, right? This has an exponent of 3, which means multiplying a times c isn't even an option. Okay, so let's see if there's a GCF. So does this problem have a GCF? Yes. A number that will go into all 3 of these is 3. Do they all have the variable? Yes. So we can factor out a 3y. So when we divide that out, that will leave us with a 1y squared minus 11y plus 18, right? These y's cancel. My GCF is out here in front. So now I'm going to focus inside the parentheses. Now this is in the form of a trinomial, and now I can factor this a times c. So 1 times 18 is 18. So we'll start listing our pairs. 1 and 18. 2 and 9. 3 and 6. 4 and nothing, 5 and nothing, right? I'm ignoring this 3y out in front. I'm just focusing on this trinomial inside the parentheses. So if we follow our rules, when this is a negative and this is a positive, we need them all to be negative. So our pair that will add up to negative 11 will be a negative 2. So it's a terrible negative. A negative 2 and a negative 9. And because a is 1, we can just go straight into y minus 2 and y minus 9 with our GCF in the front. Okay, so this will be our final answer because all of those terms need to be part of our final answer. Okay, so probably at this point you're still kind of like, I don't know, maybe kind of, sort of. So let's just look at one more to just sort of repeat that process, see if we can let it sink in a little bit. So 6w squared minus 6w minus 120. Okay, so right now, what would we do first? And hopefully we're all thinking, okay, we should be factoring out a GCF. So we want to think of a number that goes into 6, 6, and 120. So these can all be divided by 6. Now, if you didn't see the 6 and you only saw 2, right, you'd just be using that rule we've talked about before of dividing more than one time. So we'll start dividing. W squared minus W minus 20. This GCF is still part of the answer, so where are we going to write that? All right, we need these parentheses and we need it out in front. Where are our eyes going to focus next? All right, we should be saying inside the parentheses, so we're looking here. Okay, this is a trinomial. How do we factor trinomials? A times C, so 1 times negative 20. So we'll make our list. 1 and 20, 2 and 10, 3 and nothing, 4 and 5. Okay, then we need to check our signs. Okay, so we know because this is negative, we need 1 negative and 1 positive. And the larger one is the sign of B when we need one of each. So our larger one is the negative. And we need the pair that will add up to -1, right? There's a 1 there. So 4 and -5. If A equals 1, we can do that shortcut. So a W plus 4 and a W minus 5. What do we need to make sure we still include? Right, the GCF. So that still includes in our final factored answer. And so this would be our final factored form.